Friends, welcome in this class. During last three classes, we have studied about first Newton's first law of motion. Then we have discussed about Newton's second law of motion, its statement, formula, unit of force. We define the unit of force, and then we have discussed about Newton's third law of motion. And with the help of Newton's third law of motion, we have discussed different examples from different life to make it clear so that what Newton's third law of motion is. Every action, there is a reaction. These two are equal but opposite in direction. Now, during this class, we will discuss applications of Newton's laws of motion. So the laws of motion, these are few of the examples of Newton's law of motion. So we will discuss few applications so that to understand what the Newton's law of motion is. Now, number one, tension in the string. Consider a body of mass m hung by a string. This one is the body of mass m. It is hanging with the help of a string, and weight of the body is acting in downward direction. If it is an action, then reaction is acting in upward direction. This is reaction, which is in the form of tension, and it is acting in upward direction. And when these two are equal in magnitude, opposite in direction, either the mass is not moving in, either the mass is not moving in downward or it is not moving in upward direction. So the force exerted by a string on the body is tension. It is reaction force of the weight. The weight acts downward and the tension acts upward at the block. If the object is at rest, then magnitude of T is equal to tension is equal to weight. Mathematically, this tension is equal to weight and weight is equal to mg. If you apply here Newton's second law of motion, it will be if the weight is acting in downward direction, say it is plus, and the tension is acting in upward direction, say it is minus, then the sum of forces acting on this block are W minus T. Is it this block moving upward or down direction due to this force? No. Then W minus T is equal to 0. So this is one form of second law, Newton's second law of motion as well. So tension and acceleration in a string. You are asked to calculate tension and acceleration in a string. Applications of Newton's law, tension in a string. Consider a person holding an object of mass m with the help of a string. Object exerts an equal force on the hand in downward direction. That is the action which is acting in downward direction. It is in the form of weight, and hand is also applying a force in upward direction on the object, which is called reaction. Force exerted by the string on the hand is called tension, and if the object is at rest, the magnitude of the tension is equal to the weight of the body. So mathematically, tension is equal to weight, and this weight is equal to mg. So this is the concept. If you are holding any book in your hand, the weight of the book is acting in downward direction. It is action. Then your hand is holding this. If your hand is not moving up or down, at the same time, your equal and opposite force is exerted by your hand in upward direction to hold that book. So this is the condition where these two are equal. Motion of body is connected by a string. There are two cases of motion of the body is connected by a string. When bodies moves vertically, when one body moves vertically, another horizontally. These are two cases. And what's the question asked during this topic? That is, two bodies are connected with a string which passes over a pulley, frictionless pulley. You have to calculate tension and acceleration. But the other case is when one body is rest on a table, other hangs vertically. Both are connected with a string which passes over a pulley, and you are again asked to calculate acceleration and tension. So we will discuss the first case, that when body moves vertically. Suppose two bodies A and B. This is the explanation. A and B having masses M1 and M2 respectively are connected to two ends of an inextensible string passing over a frictionless pulley. This is the case. M1 is greater than M2. Then body A will move downward and body B will move upward. This is the condition when the one will move in downward. Other, if the both are same, both will be one both will be applying force of the same magnitude. One will be action, other one will be reaction, so they will be at rest. So what is the possibility? Possibility is that you have to keep one mass small, other one large, so that it can move up and down respectively. So this is the case. If you look at, these are the two masses. This is frictionless pulley. This is body A. Its mass is weight is m1g. Similarly, tension is acting in upward direction. And the case of body B, weight is m2g W2, and tension is acting in upward direction. This is body B. It's heavier, it will be moving, of course, in downward direction. This one is lighter, it will be moving in upward direction. So you have to calculate the total number of forces acting on body A. Then you will get one equation. Then you will apply the same technique, number of forces acting on body B, and it is moving in upward direction. Force is acting on a body of mass m and it moves, acceleration produced. You will apply Newton's second law of motion on this body. Similarly, you will apply Newton's second law of motion on this body, and you will get two equations. And after equating these two equations, you will be able to find out acceleration and tension. So let's start. The force is acting on body A. As the body A is moving in downward direction, the resultant force acting on it is downward, due to which acceleration is produced in it, because it's not free fall, so that's why acceleration is produced. Net force acting, that will be, if you look at the net force acting on the body A, that is m1g minus t. Why? Because the body is moving in the favor of weight, that is m1g, and where it is moving, what about the other force? Tension is also acting, but its direction is in upward direction. If you sum up these two, you have to place a bracket, and inside bracket you will take negative sign with the t to represent the opposite direction. When you will simplify it, you will be getting m1g minus t. I hope you understood it. According to Newton's second law of motion, F is equal to ma. This is formula to calculate force on a body of mass m. When this m is moving up or down, it must have some acceleration. So you will use formula of Newton's second law of motion to calculate force. So here it is, F force acting, that is, because body is moving in downward direction, it is plus weight, minus because it is moving against tension, you have to take negative sign. There is another logic. If one weight is one force is increasing, other one is decreasing. Of course, if the body is moving in downward direction, weight is more than the tension. The object which is more, it is taken as positive. The object which is less, it is always taken negative. The object which decreases, that is taken as negative sign. So if you look at, you see that m1g minus t, that is force acting. If this is a body of mass m1, force acting will be m1a. So because the weight is downward direction, tension upward direction, this is the total forces acting on this body. You have sum up, you have added these two forces acting on body A. Negative sign shows that the direction is different. Weight is downward, tension is in upward direction. So that is equal to m1a. This one is equation 2. So forces acting on body B. What are the forces acting on body B? Follow the same sequence. One is weight acting in downward direction. It always acts in downward direction. The tension is acting in upward direction. So what's the difference between the two? Here, in this case, tension is more than the weight. Then the tension will be in positive sign and the weight will be with a negative sign, because weight is decreasing when the object is moving in upward direction. The force of attraction between earth and the mass is decreased. So that's why it is moving in upward direction. You will replace negative sign. You will place negative sign with the weight. So it is T minus M2G, that is M2A. And it's equation number 2. This one is equation number 1. So calculation for acceleration, you are getting two equations. You have to see how you can calculate the acceleration. If it is M1A, this one is M2A. If it is plus tension, this is minus tension, then you will add these two. You will use the simple mathematical equations uh, to find out the value of acceleration. So this is plus t minus t, this one is plus t. If you add these two, plus t minus t cancel, then the remaining equations are, look at, you are adding these two. This one is m1g minus t plus t minus m2g, that is equal to m1a plus m2a. This plus t and minus t is cancelled. The remaining one is m1g. Here it's minus m2g, and you have separated the factor where you can take the common to one side, that is small g is common along this side. that is along the right side, there is a other acceleration. This acceleration is, you will take the common. In mathematics, you have to see the simplest type of option or the minimum option. Minimum option is that if you can add these two, you go ahead and add. If you can't add, then see if there is any common from these equation. So you will do a action. You have to take a step. You have to separate these terms where you can take one factor common. You have taken m1a m plus m2a. You can take a common from this place. Similarly, you will take g common from this side. So that is this one. A is equal to m1 minus m2, m1g minus m2g. That is m1 plus m2. You have taken a common from this equation. So you are getting value of acceleration. So this was one of the tasks to calculate. Now, how will you calculate tension? See, again, the previous equation, you are getting two equations. Number one is this one tension, another one is this one. So you are supposed to calculate tension. What will you do? If you divide equation 1 by equation 2, acceleration A, this one will be cancelled with this one acceleration. Then finally, you after simple mathematical simplification, you will be able to calculate the value of tension. Okay, and you got the value of tension with simple mathematical calculations. These are the mathematical calculations you're taking to one side and you're taking the other to the other side. Another simplest option you can follow is that if you divide equation 1 by equation 2, you will be able, it will be more easier for you to calculate the value of tension. So this is the value of tension, finally value of tension which you have calculated with the help of mathematical steps. So the above arrangement is known as Hartford machine. It can be used to find the acceleration due to gravity. That is, this one is acceleration due to gravity. Number two, case two. Case two is when one body moves horizontally, the other one vertically. The two bodies of masses m1 and m2. This is explanation. Respectively, are connected to an inextensible string which passes over a pulley. One moves vertically downward with an acceleration A, the body B moves horizontally to the smooth surface towards the pulley with the same acceleration A. The value of T is same. Value of T, the tension is same. So this is the figure. If you look at, let's first of all understand from the figure. This one is body A. The body which is hanging vertically. This one is body A. It hangs vertically. It is larger than the body B. So the tension is acting upward towards pulley, weight is acting in downward direction. So here is another mass which rests on horizontal table. Its weight is acting downward direction. The tension is, or the reaction is acting in upward direction. Look, these two are equal and opposite. These two forces will cancel each other. There will be no force acting along vertical direction. The force only acting along on the block will be the tension from pulley to the block, which will be responsible to produce the acceleration in body B mass. So let's start from body A. What are the forces acting on this body? Weight acting in a downward direction, tension acting in upward direction. Same logic which you have followed during the previous case. That is, in this case, the weight is more than the tension. So that's why the weight is moving in downward direction, body is moving in downward direction, then the tension is less. Then what the type of equation you will be getting? Of course, acceleration is produced, then it will be m1g, because tension is decreasing, minus t, that is equal to m1a. This one is m1g. This is the first equation which you are getting with the help of applying Newton's second law of motion, because net force is acting on this body of mass a, mass m1, and the acceleration produced. Net forces are m1g plus because it is moving in the favor of weight, minus because it is moving against tension. So you sum up the forces acting on the body A. So these are the two forces acting, m1g minus t, that is equal to m1g. So this one is equation 1. So look at equation number 2. What type of equations you will be getting? Weight is acting in downward direction, tension reaction is acting in upward direction. They cancel each other. There is no motion along vertical direction. So what will be the force acting on body B? That is tension. It is producing acceleration in body B. Then T is equal to m2a. This one is the second equation. Look, this one is the second equation. T is equal to m2a. Upward reaction on horizontal table acting on the body is in upward direction. Tension is on the string push the body towards the horizontal direction. This is detailed explanation. If a body B is not moving vertically, therefore the force cancel each other, which I have already discussed. Weight is cancelling the R reaction of the table because there is no motion along vertical direction. So which one is the only remaining force? This one, T, due to which body moves uh, in horizontal direction with acceleration. According to Newton's second law of motion, you will apply force acting on the body and acceleration produced. That is tension acting towards the pulley and producing acceleration in the body of mass m2. Calculation of acceleration, again, you will use technique to calculate the acceleration. These are the two equations, m1g minus m2a, that is equal to m1g, and again m1g, that is m1a plus m2a. You have to see what's your target. Your target is to calculate acceleration, then of course you will add up, and the tension will become cancelled, and then you will be getting value of acceleration, that is a is equal to m1 divided by m2 and m1 plus m2. Calculation for tension is very simple. Put the value of acceleration a in equation t is equal to m2a. This one is m2 and this one is value of acceleration which you have calculated with the help of equation number 1. You have placed the value of acceleration in this m2a. This one is the acceleration value. First you will get acceleration from by using equation 1 and 2, and it's very simple. For calculation of tension, write on one of the equation, use simple mathematical rule, T is equal to m2a, put the value of acceleration in this equation, and then finally you will be getting value of tension. So with this, we have completed uh, main two applications of Newton's laws of motion. And what were the cases? There are two cases. And in these two cases, what's the difference? Difference is that during first case, both the masses hangs vertically, this one, and you have calculated acceleration and tension. How you have calculated body A is greater than, larger than body B. You are getting one equation with the help of body A, then you got another equation with the body B, and acceleration is produced. You are applying Newton's second law of motion. Sum of forces is equal to m1a, and sum of forces acting on body B is equal to m1a. If one is plus, other one is minus. Here tension is increasing and weight is less, so that's why tension is plus, weight is minus. Here weight is plus because it's moving in the direction of earth, and tension will be less because it is moving against the tension, and tension is decreasing. You are getting two equation by using these two equations mathematically simplification. You have done a very simple calculation. After this, you have calculated acceleration as well as tension. Now, when we have discussed case B is different. One body is resting on horizontal table. It is connected with a string which moves over a frictionless pulley. Another body hangs vertically. Body A is greater than the body B. Then it is moving in downward direction. The block is moving on the horizontal table towards the pulley. We have applied say Newton's second law of motion on body A. We calculated equation A. Then we have applied Newton's second law of motion on body P. Here we have already cleared that the weight is equal to reaction. They cancel each other. There is no motion along vertical direction. So that's why only tension is responsible to move the body. Tension in the string towards the pulley is responsible to move the body towards the pulley. So with this we have again we got two equation, and by uh, mathematical rules or the laws, following the same rules and laws, we have calculated tension. It depends on you which step is easier for you. If you can add these two equations to get the value of one physical quantity, add it. If you can divide these two equations, get the value of one physical quantity. Or if you put the value of one quantity in the next question, next equation like this one, t is equal to m2a, you have placed the value of acceleration in this equation 2, and you got this equation 2, and you got the value of tension. These are some of the few important steps to calculate. So what you have done, you have calculated acceleration and tension by using these two cases. With this, our class ends. I hope you have enjoyed and you have understood it. Thank you very much for your patience.